Hello, Honors Algebra. Mr. Lawrence here with your flipped lesson for Monday, February 27th. Hopefully you listened last week and know you have to watch this video because Tuesday we will be working on this. It's a new type of factoring. It is factoring trinomials. I just call it the trinomial method. As far as I know, it doesn't really have a name. Call it factoring trinomials. And you guys are lucky because when I had to do these back when I was in school, the teacher only taught a guess and check method. Now I was really good at my math facts, so that made it simple. But since then somebody came up with a technique, it was not me, where you list factors of numbers and makes it a little more concrete. So let's take a look at a problem, say like this. X squared plus 7x plus 12. All right. Now, this doesn't fit any of the patterns that we've seen before. So here's what we're going to do. Now, since the lead coefficient right here, the lead coefficient is 1, right? This is a relatively easy problem to do. When that lead coefficient is not 1, this becomes a little trickier. But if you're good at your math facts, which I've told you need to know, this will be an easier problem. What I'm going to do is off to the side here, I'm going to list the factors of 12. 1 and 12. And I'm going to list them in order, not just haphazardly. Start with 1, put 12 there. 2 goes into 12 6 times. 3 goes into 12 4 times. I know I have all the factors of 12 because the 3 and 4 are converging to the same number. I only have to check whole numbers. I don't have to check negatives or anything like that. All right, now there's something important to know here. You see the sign right here? The sign on the third term? This sign is positive. If this sign is positive, you know you're going to add. Okay? If the sign were negative, you would subtract. I know you don't know what to add or subtract yet necessarily, but what I'm going to do, I'm going to take two factors of 12. I have to take two factors that multiply to get 12. For example, I can't take 1 and 6. If I take the 1, I have to choose 12 with it. If I take the 3, I have to choose 4. All right? My goal is to make the middle coefficient, the 7. My goal is to make the 7. Well, I'm sure a lot of you see already that 3 plus 4 equals 7. This is how easy this is going to factor. The quantity of x plus 3 and the quantity of x plus 4. Okay? Now, another thing I want to tell you is that since this is positive, we're going to have a Wendy's double stack, and this sign is going to show up twice. Okay? That's because the third term was positive. If the third term were negative, you'd have one sign of each, and actually you could have a plus or minus on the second term there. All right, let's try another one. And again, we're looking at simple examples here. All right, let's do 1 second. Okay, it is a trinomial. It doesn't fit any of the other patterns. 27 is not a perfect square, so I won't even examine the perfect square trinomial situation. By the way, you know, through my mind, what I'm doing is I first would check the GCF. Second, since it's a trinomial, I would see if it's a perfect square trinomial. And x squared is a perfect square, but 27 is not. So now I'm moving on to the trinomial method. So I'm going to list the factors of 27. 1 and 27. 2 doesn't go in evenly. 3 goes in 9 times. 4 doesn't go in. 5 doesn't go in. 6 doesn't go in. 7 doesn't go in. And 8 doesn't go in. And I know I'm done because these converge to a center. So all I have to do is check all the numbers between 3 and 9. And I have all the factors. All right, this third term is positive again. So I'm going to be adding. I need to add 2 of these numbers, either 1 and 27 or 3 and 9, to get 12. Well, I think you realize that 3 plus 9 is 12. Now, it's not going to factor as x plus 3, x plus 9. Remember, the second sign here, this is a negative, that's going to be my Wendy's double stack. So it's going to show up like x minus 3 and x minus 9. You might think of this as, excuse me, you might think of it as adding 2 negatives to get negative 12, because that's exactly what I'm doing. All right, let's look at a different one. Okay, again, here's x squared minus x plus 56. Oops, I don't want to do that. I want to make it minus 56. Sorry about that. There we go. All right. So I check for the GCF. The only GCF I find is 1. It doesn't do me any good. I move on. Trinomial, perfect square trinomial. 56 is not a perfect square. There is no number times itself that equals 56. So I will move on. No rational number, I should say. All right, so now I'm going to list the factors of 56. So I'm going to get 1 in 56, 2 in 28. 3 does not go in. You know how I know? Because 5 plus 6 is 11. If 3 is going to divide into a number, if you add all the digits together, you get a multiple of 3. You know, 3, 6, 9, 12, 15, 18. And 11 is not a multiple of 3. 4 will go in. And I believe it's going to go 14 times. You know how I know? I multiplied 2 by 2 to get 4, and I divided by 2 here. I did inverse operations. In other words, multiplying the 2 by 2 and dividing the 28 by 2 is the same thing as multiplying 4 times 14. Let me explain that again one more time. You should know that 2 times 28 is 56 from earlier work in the problem. That means that 4 times 14 must also be 56 because I multiplied by 2 here and I divided by 2 here, and these guys are canceling each other out. So while they make the numbers, their factors look different, the ones they're being applied to, they don't change the value of the product, which is 56. Okay, that would work for any numbers. If I, just to take a ridiculous one, if I multiply this guy by, say, 7, and then I divide by 7 here, well, look at that. I picked those accidentally, I guess maybe accidentally on purpose. I got 14 times 4. Okay, we know because the commutative property that 4 times 14 is the same as 14 times 4. But if I did, say, I don't know, times 11, divided by 11, all right, that's going to come out weird. 28 divided by 11 isn't going to come out pretty. But if my logic is right, and let me check myself here, I know I'm going to get 22 here. I'm going to get some kind of decimal. Hold on one second. Let's see here. 28 divided by 11 is, and the 5, 4 repeats. Now you want to be careful when you check. Make sure if you're going to check at home, you're not going to use 2.54 because it'll come out slightly off. So I'm going to use 2.54 and the 5, 4 repeats. And if I multiply that by 22, sure enough, I get 56. Okay. So anyway, just a little bit of number sense there for you. So 4 goes into 14. Now, I'm not done with my factors. I mean, I might be done, but I don't know if I'm done because I haven't checked the numbers between 4 and 14. So I'm going to move on to 5. Does 5 go in? No, it can't because the number doesn't end in 0 or 5. 6. I know 6 doesn't go in. You know how I know? 3 didn't go in. 6 can't go in. Yeah, I said 3 didn't go in. 3 goes into 6, right? For 6 to be able to go into 56 evenly, the factors of 3 are going to have to go. 2 goes, the factors of 6 are going to have to go. 2 goes in evenly, but 3 doesn't. Okay. 7, yeah, I think 7 times 8 is 56. And I'm done because there's no whole number between 7 and 8 that I have to check. All right, so now, because that third sign is negative, I'm going to be subtracting. Remember I said that earlier? Subtract. Okay. I need to subtract 2 factors of 56 to get an answer of, some of you are thinking, how do I get a negative x? You're not getting a negative x, silly. You're getting a negative 1. Well, what about a negative 8 and a positive 7? What about that? Yep, I think that would be negative 1. So here's how we factor. We can go x plus 7 as a quantity and x minus 8 as a quantity, and we are done. All right, this is the trinomial method. Again, I strongly suggest you know your multiplication facts. 12 by 12 grid, learn them all the way up. You know most of them already. I mean, seriously. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm running out of room. Slide them over. $10, $11, and $12. And then do the same thing and just write it a few times. I mean, how hard are some of these? They're so simple. I mean, the ones are cake. They're all the same. 2, 2, 4, 6, 8, 10. I mean, that's not difficult. All right, the 5s you probably know. Get on YouTube, watch Schoolhouse Rock. 5, 10, 15, 20, 25, 30, 35, 40. Learn your 3s on there. 3 is the magic number. Easy stuff. Okay, you only have a few sets to memorize, but smart as you guys are, by a week or so, you could have them all memorized through the 12s. All right, it's just too easy to not know. Don't tell me you need your calculator, because if you rely solely on your calculator to do these factoring problems, you are going to want an extra hour for the test, and I'm not going to give it to you. All right, enough said about that. I expect you to come in Tuesday, guns a-blazing, ready to do some factoring trinomials. Mr. Lawrence signing off. Have a good night, everybody.